The changing seasons of the year. One season giving way to another as the Earth moves around the sun. For the Earth travels around the sun once a year, and during this time the seasons change from summer to fall, from fall to winter, from winter to spring, and from spring back again to summer. In the wintertime, the sun rises late in the day, and it sets early in the afternoon. As a result, winter days are short, and we usually spend more time indoors. In the summertime, we get the opposite, for now the sun rises early in the morning, and it sets late in the evening. This gives us long days and short nights, and we can spend more time outdoors. Why do we get this change in the length of our days and nights? Well, as the Earth turns on its axis, half of it is in sunlight and half in darkness, giving us day and night. It'll help us if we draw a circle around the Earth where day and night meet. We'll call it the circle of light. Now, the change in the length of our days comes about because the Earth is tilted. Its axis is at a slant to the sunlight. Let's see how this tilt alters the length of our days during the course of a year. The Earth is now moving towards September. If we stop it at its September position and turn it around, we can see that our circle of light passes through both the north and the south poles, cutting the world in half. This means that the days and nights will now be the same length, 12 hours of daytime and 12 hours of night. This condition is called the September equinox. The word equinox comes from the Latin and means equal nights. As the Earth moves on to December, it reaches a position where, because of its tilted axis, the circle of light no longer runs through the poles. Instead, the circle falls short of the North Pole, but goes beyond the South Pole. This means that it will always be night at the North Pole, and always daytime at the South Pole. Furthermore, in the northern half of the world, because the illuminated side is smaller than the darkened side, the days will be short and the nights long. In the southern hemisphere, the opposite happens. Here, the illuminated side is larger than the dark side, giving us long days and short nights. This is called the December solstice. Continuing its journey around the sun, the Earth moves on to March. Turning it around, we notice that once again the days and nights are of equal length. In other words, a second equinox takes place. This is the March equinox. Finally, when the Earth reaches its June position, a second solstice will take place. But this time, the circle of light stretches beyond the North Pole, but doesn't reach the South Pole. Now it is always daytime at the North Pole and always night at the South Pole. Furthermore, in the northern hemisphere, the illuminated side is now larger than the dark side. and so the days are long and the nights short. While in the southern hemisphere we get the opposite effect: short days and long nights. But the tilt of the Earth's axis does something more than just change the length of our days and nights. This same tilt also gives us the cold of winter and the heat of summer. In December, when the North Pole is tilted away from the sun's rays strike the northern half of the world at an angle. Because they hit the Earth at this slant, the rays are spread out over its surface, and their warmth has to be shared by a large area. As a result, the northern hemisphere never gets a chance to get very warm, and we have the cold of winter. In the southern hemisphere, where the South Pole is tilted toward the sun, the reverse happens. The sun's rays strike the Earth from almost directly overhead, and so the same amount of sunshine covers a much smaller area, giving the people who live in the southern hemisphere the heat of summer. In June, things are changed about. This time it is the North Pole that is tilted towards the sun, and so the sun's rays are concentrated in the northern hemisphere, making it hot, and spread out in the southern hemisphere, making it cold. We have seen that the tilt of the Earth not only changes the length of our days, but makes them hot in summer and cold in winter. We've also noticed that when it's summertime in the north, it's winter in the southern hemisphere. Now let's put all these facts together and watch the gradual change of the seasons as the Earth makes its yearly journey around the sun. As the Earth moves towards December, the days get gradually shorter in the northern hemisphere. They also get colder, for now it is fall. In the southern hemisphere, however, the days grow longer and become warmer. Here it is spring. Now the Earth leaves December behind and moves on to March. In the north, the days are still cold, but they begin to grow longer. While in the southern hemisphere, the days are still warm, but begin to grow shorter. Now it is winter in the north and summer in the south. As the Earth moves between March and June, the days begin to get longer in the northern hemisphere, and at the same time gradually turn warmer. It is springtime. On the other hand, in the south, the days get shorter and colder, for here it is fall. Finally, the Earth moves on to September. In the north, the days are still warm, but they start to get shorter again. While in the southern hemisphere, the days stay cold, but gradually become longer. Now it is summer in the north and winter, and so as the Earth makes its yearly journey around the sun, the length and the warmth of our days gradually change, giving us the variety and beauty of the 4 seasons.